Today on the IoT Show, I have Hugo from Electric Imp. He's going to show us how their fantastic board connected through 4G is able to connect to IoT Central. There's a seamless integration between the Electric Imp solution and the Electric Imp Cloud and IoT Central, and we'll show you that in a second. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today we have Hugo from Electric Imp that's going to talk to us about the integration between their technology, the one that they've been developing for devices, and Azure IoT. Hugo, thanks for coming on the show.
Thank you.
So, not everyone knows Electric Imp, not everyone knows you. How about you introduce yourself and what Electric Imp is about?
Okay, I'm Hugo Fiennes, co-founder and CEO of Electric Imp. My background is making lots of stuff. I made lots of MP3 players back in the early 2000s, made lots of consumer devices. I worked for Apple. I made the first 4 iPhones. I was hardware manager for iPhone for the first 4. Did the Nest thermostats, my first journey into IoT.
Nice.
When I was doing that stuff, I kind of realized how much of IoT is a big software problem, and actually how badly served it was by sort of chip vendors going, "Hey, just buy a chip. Here's IoT on a chip." As Microsoft, I'm sure know, the really hard problems here are software.
Yes.
IoT is a huge stack of software that has to work well to give you security and make sure stuff just works. I mean, you learn at Apple that making stuff look easy is very, very hard.
Yeah.
And that's pretty much that. So the founding of Electric Imp came about because I've been working on the Nest thermostat. I did the hardware design for the first product. Still have serial number 1 on my wall. It still works.
Rad. I like that.
But I was doing this and going like, well, hang on. There's if you're Tony Fadell and you can hire people from anywhere and you have lots of money, it's fine doing your own IoT stuff. But most manufacturers aren't in that position. They're in a position where they have a need for data. They have a need for analytics, connected machines in manufacturing or in the field or whatever for service reasons. However, they really don't have, there's nowhere for them to go to build the stack to do this. So they go to silicon vendors and they'll get something which works, maybe isn't secure, isn't updated usually.
Yeah.
All the issues like that, but there's a huge amount of integration and plumbing and everything to get this to work. And if you're a business, really, about IoT is really about data. It's about what can you do with the data, how your business will transform. So Electric Imp was like, okay, well, we'll just deal with the connectivity and the data and keeping a device online for a decade. How you do that type of stuff. Will other people like Microsoft deal with analytics and storage, because that stuff, really deep knowledge, AI, ML, all that good stuff. But really, my background is a lot of building things, very low power things. MP3 players that ran for 24 hours with 1 AAA battery. Which back in the time, that was it. That was the really impressive thing.
Just playing music, by the way.
Just playing music,
making coffee, whatever, right?
no. I think it did Microsoft Plays for sure back then, but that was quite hard on 1 AAA. But so that was essentially what we did. So built a really good team that knows all this stuff and made a very power optimized, security optimized sort of platform to build stuff on. There's a couple of million devices on the platform right now in various applications, everything from consumer to things like postage meters. Pitney Bowes use us to connect their postage machines. And one of the most recent things we've done is we now have cellular. Which is kind of fun. I mean,
part of the chip, right? So you're building the chip, right?
So actually, it's true. We started off building the chips because we needed to build secure hardware, and there was nothing off the shelf we could buy. But actually, once we got to a certain volume point, we worked with Murata, who built the Wi-Fi devices. And so they're all preloaded with our OS, preloaded with keys and all that type of stuff. So they're really easy to use. You just solder it down, and it's already secure. For cellular, right now we're building them, but we expect that to transition away over time. But really, it's like, I think that's the whole thing about, as obviously Microsoft defining it as well, building your own hardware means you get to say exactly how it should be. And after that point, other people can make it. But the point is it's very hard to iterate with an external manufacturer. So we have cellular is pretty interesting because it's not just a piece of hardware, it's not just a service, it's actually the SIM is embedded, and you don't even think about SIMs. Traditional cellular devices, it's like, oh, well, here's the device, and then there's a SIM, you've got to speak to a carrier, get a service plan, work out how much you're going to spend a month. Our stuff, all of that stuff is just gone. You don't have to think about any of it. You just power it up and it's online. It's very sensible pricing. It's very cheap data. It works anywhere in the world.
Nice.
It's just like hey guys, you just want the data, right? Okay,
yes,
we'll do that.
Got it. So you're basically sorting out all these tough problems that are coming down there. And you're mentioning security, which I suspect includes also maintaining, the software. We're talking about that just before starting recording. That as soon as you have one line of code, potentially you have a bug or you have a security hole, whatever. So you need to maintain that, and you need to catch up on whatever the hacking technologies are doing, and you need to update the software. You need to maintain it. You need to monitor that, right? Absolutely.
And I think that's what we were saying just before we started was actually that this thing that any experienced programmer knows, like every line of code you write is a line of code you're going to have to maintain.
Yep.
And actually device manufacturers tend to be very product-centric and cyclical. So they'll work on a project, they'll ship it, and then move on to the next one.
Okay.
And getting the management, they don't understand really well sustaining engineering, which is a big thing. Obviously, Microsoft do it a lot, maintaining Windows and stuff. Sustaining engineering is a way of life. It's a way of design. And most product companies aren't good at that. And I think that's one of the reasons why IoT has got a bad security rep, is people make stuff and it may be secure the day they ship it, insecure the day after, and they're going, hey, all the engineers want to fix it, but they don't have the budget, they don't have the time, they're pulled in different directions. So for us, we separate the operating system and the application, even down on the smallest thing with like 100K of RAM. They're separated, and it means we can update the operating system under the application. So this allows us to maintain it. Even the first products we shipped back in 2012, still running, still fully maintained, still got the the latest TLS, forward secrecy, all this good stuff.
Nice.
And our customers haven't had to lift a finger to do any of that. So it's really the separation of operating system and application, which is it's normal in every other bit of computing aside from embedded. But embedded, everyone's like,
as you were saying, it's hard. It's not something simple. And what I noticed as well, that companies would want to do IoT stuff, they might be coming from a different world. And so embedded development is new to them, or vice versa. People are doing embedded and they have no clue what's going on in the back end. And we're seeing actually the people from embedded were trying to do data analytics and big data and stuff like that, and just like totally at a loss with that. So we were actually tying things together. And actually the demo we're going to go to is actually that integration between these two worlds, like made easy, made simple, like extremely simple, like the simplest way of programming for a tiny device like that, where you guys maintain the OS and so on, establish the connectivity, and the simplest ways of doing IoT in the cloud, which is IoT Central. Like click, deploy, and you have a full solution there.
So and I think it's really important that separation and thinking about making it data centric. And it's interesting because we have some customers who actually the web developers, there's a lot of people know JavaScript, and actually it's a scripting language that runs actually on the device. And we have a very interesting architecture, which I'll talk about in a second. But essentially, we've had web programmers write embedded code. And it's fine. No,
that's my reaction.
That's your reaction. But actually, this is the new world, because there's way more JavaScript programmers in the world now than there are embedded C++. And the fact of the matter is, with IoT, the demand for embedded knowledge has gone through the roof. And it's one thing to be able to write some code on a Raspberry Pi. There's another thing to be able to write something which can last 10 years, deals with all the edge cases, is power optimized, all the things like that. And a lot of our system, the way our OS works, makes that much easier. It's all event driven and stuff like that. So the concepts are very much like you'd expect in web stuff. You can use promises and all this sort of stuff, which is trendy in web stuff on embedded.
The concepts are translated or actually implemented on your platform. That's what you're saying. Interesting. So you have a diagram here about this like IoT solution architecture. Can you walk us through a little?
Talk about it. So we'll start at the device side, because that's kind of what people kind of think about. So down here, there's Imp OS, Electric Imp. So this is essentially hardware and our OS. So we don't run on any hardware platform. There are certain curated ones because we have to test them. So we actually run, I think it's now over 7,000 system tests, automated every 2 hours on all of our stuff. We have to make sure that our OS never aggresses power, latency, I/O behavior, anything. So we have a really, really big test setup on that.
You don't want to break a device that is
under
the dirt, like for the next 10 years, and you cannot change. Definitely.
Many of these devices are very remote. We actually have got one customer who they put them in walls to monitor the plaster drying. So that they put in the wall and
they
won't
touch
forever.
them.
They're there forever. When the plaster is dry, it's done its final reading, it's just dead in the wall.
Interesting.
But anyway, so down here there's our OS running on the secure silicon, and it runs the application. And you can put it in a retrofit or new product. Often retrofit, it's actually you're using an existing communications interface, a USB, a UART, whatever, to talk to the device in the field, RS485, Modbus. Or in a new product, you can actually have, a lot of people don't run a separate MCU. They actually run their application in within our secure boundary, which is nice. It protects your IP, a lot more consistent behavior and so on. They have these maintain secure tunnels. It can actually be a nailed up connection online all the time, depending on what power you have, or it can be a sporadic. Some people have them, they check in once a day, whatever. It's a TLS 1.2 tunnel, forward secrecy, all that stuff. Now the really interesting bit here is that for every single device in the field, there's a partner virtual machine in the cloud. So the traditional IoT stuff is you'll have on the device side, you'll do all your I/O, and you're also having to talk to a complex API in the cloud. You're having to do cloud authentication and so on. This one it isn't. This is a mutually authenticated tunnel. But all your cloud integrations happen from your cloud virtual machine. So essentially, these two VMs can exchange messages however they want. We do almost 1 billion messages a day through our system. But you get another VM here. The nice thing about the VM running here is it runs 24/7. It's running in a data center. It can talk to anything. It's pretty much assured connectivity. But also, it doesn't burn power. So this is actually a nice thing.
It doesn't burn power that the customer has to pay for.
but if you have batteries, if you have batteries, it's more the battery, the changing battery things.
Makes sense.
But the nice thing about it is, I can have a device which pings in once a day, but I can hit an API here and find its latest reading or tell it to do something the next time it connects. And I can implement those complex behaviors. It also means I can have a very nice API and evolve that API without running out of space on the device. But some of the problem that people haven't really thought of on IoT is what happens in 10 years' time? I have 4 generations of hardware in the field. My data guys are going like, not another API, we don't support another device. This one, you can have the same unified API for every generation, and the wiring is hidden.
Got it.
You could call this middleware. I mean, middleware is ugly, but it exists everywhere.
It's a new type of thing.
It's a new type of thing. So, and here, also in the cloud, there's security maintenance. We monitor devices. We monitor exceptions and so on devices. You can deploy to all your. We have people who one-click and deploy to 300,000 devices. Done. It's very hard to brick a device on this because it runs a virtual machine. And this is delivered, there's a Azure public cloud, so you can use a public cloud, which is multi-tenant, so our customers just pay for what they use. Or you can have your own cloud. So if you have your own cloud, you have your own keys, these are HSM, root of trust, all that type of stuff. So you can have your own cloud, which is so only ever your traffic will go through it, and you have escrow and stuff. And so here we have it hooked up to Azure IoT Hub and IoT Central.
So there's a bridge between the Electric Imp cloud and the Azure IT infrastructure.
So the nice thing about this bridge is this isn't a black box. Essentially, the entire integration is open source. It's BSD licensed. It is on GitHub. All the integration actually runs within the VM. So our VM provides MQTT primitives, HTTP primitives, JSON encoding, decoding, HMAC hashing, all that type of stuff. So you can build any integration you want. We provide example ones, IoT, Azure IoT Hub being one of them. But the point is, if you don't like it, fork it, do what you want, change it. And the point is that you do have people who have a device and it's like, we're feeding all our data into Azure. However, we have a customer ID. We have to get out of SAP when the device is provisioned. You can make that happen here. You can make this call out to SAP API, grab that thing, and then augment the data with it, or even do data filtering and so on. So it's a different way of doing IoT, but really it's the realization that in almost every IoT application, you end up, there's always a Python script running somewhere which ties something together. That doesn't scale. It's like fine for maybe 1,000 devices, then you get to 10,000, it's like, I've got to re-engineer this, and it becomes an IT project, becomes a support burden. With this, all the glue is actually deployed as part of the platform. So it's our problem to scale it.
So you have this, this glue, this connection actually outbound, but there's also the notion of if you're an Azure developer today, you have an IoT Hub solution or IoT Central solution that uses a park at different types of devices, and you want to add the Electric Imp once, it's going to be seamless for you. You're going to see just like a set of new devices that will come up, and they will be acting as if they were like other types of devices, but in that case, they're Electric Imp one, and the hub will interact with that VM here that represents the device which is in the field, basically, right? So it's like there's something, there's the concept of device twins, which IoT Hub does support. This is actually, because you're actually running code there, you can have other sort of more fine-grained functionality. It might be like, well, here's the latest data, but actually if it's more than an hour old, throw it away because it's not useful in our application. And you can do those type of things actually within the system, which is actually pretty powerful. I think we've got that device here, right? It has like a GPS, it has the antenna for GSM connectivity, and then so tell us a bit about the device and show us how we're going to use that one.
Okay, so I'm just this device. This is our breakout board. So this is the cellular breakout. The cellular device is this one here. It's a little M2 form factor. And the idea is generally you put this on your own board, and you just put the socket on, you plug it in, and it's done. Right? Yeah, just this part. And this has FCC approvals. It has PTCRB. You don't need to do any carrier or radio approvals.
And the connector is standard?
It's just a standard M2 connector. Okay. Yeah. So the nice thing about it is that this is an evaluation board. So essentially, it lets you do lots of different things on there. It has a battery charger, it has a gas gauge, it has a temperature humidity sensor, it has an accelerometer, and it has obviously a tricolor LED you can flash things with.
You need blinky dem on that for sure.
But it also has some other bits. Like here, this is actually a connector for what's called a Pixhawk GPS.
Okay.
This is an off-the-shelf drone GPS unit, which is kind of nice. It's actually not picking up anything that would be flashing green, but we are inside.
Like the building,
Yeah, it did actually work just outside, but you're close to a window. But also you have USB host. USB host is built in, so you can plug in obviously many devices, printers, scanners, anything you want there. A couple of Grove connectors, so you can plug in other random sensors.
Diverse kits there.
And there's also a microbus connector here, which actually you can drop a lot of things in. We've got people who drop in Zigbee modules, LoRa WAN, current loop.
Yeah, so you can actually use that device or like that demo board actually as a gateway for like local network and field network type of things, right?
And this shape actually also fits into an IP67 housing, so you can buy an off-the-shelf housing to make it waterproof. But it's power optimized. It'll sleep down at single-digit microamps, all that type of stuff. But it's a great dev board.
It is.
And these are just available on our web store. But it's a good way to get started. You can try your application out. The other actually thing about this, which isn't shown on this one, but actually you can put on, there's the support for this is coming in a future software release, Bluetooth LE and Wi-Fi. So you can actually have multi-protocol. So you can have something which is natively on Wi-Fi, but then if Wi-Fi goes down, it'll fall back to cellular.
Got it.
And you only pay for cellular in the months you're using it, which is kind of nice. So you've got great backup solutions. But the actual device will also support Ethernet, just not on this board. So actually it can do multiple networks. We have a built-in Bluetooth stack. You can do stuff like we have some customers who are monitoring Bluetooth assets. They have the tiny little cheap little Bluetooth tags on things. And then one of these in a vehicle. So actually the cargo can report into the device. It can then augment it with a position and send it up to the cloud.
Love it.
Which is a really neat solution.
Yeah, I love it.
And it's very, very compact and power efficient.
Yeah, love it. How do you program that one?
So this is programmed.
I want to see that
online with our IDE.
So all in the browser.
So this is we have an IDE now. It's always impossible to make an IDE that people like. So essentially the IDE
everyone likes.
Everyone likes, yes. So the IDE is really a good way to get started. There are command line tools. Generally most customers will use something called Imp, which is a command line tool. And then you can have your Git integrations and multi-file support and stuff. But this is really a very simple way of actually getting started. Very visible. So one thing here is there are two sides. There's two code panes here. This is the agent code. This one on the left is the code that's running in the cloud. So you can see here we're pulling in a Google Maps agent here to do device location. There's your IoT Hub. And it's object-oriented. This is a language called Squirrel. Whoops. I'm going to scroll with. I'm not used to a PC here. If you're a C programmer, if you're a JavaScript programmer, it looks very similar. And there's like kind of 500 lines of code here.
Can you reuse existing libraries that are found out there?
No, because you can translate JavaScript ones fairly easily, but it's not. One of the reasons actually we picked Squirrel. It's a language called Squirrel, which is a game scripting language. We were using Lua at one point, but then it was just Lua really did my head in as a C programmer. It was a big mind shift to make that work. But it's very, very simple to translate if you need. The problem is if you support JavaScript, then people immediately pull one bit of node in, and before you know, there's like 10 megs of node code coming.
Yes, you don't want to
and that's actually hard to make it scale. So it's very easy to use, but it's not quite the same.
But anyways, you provide diverse libraries to access diverse types of buses and inputs and outputs and so on, right? So you already have that.
Yeah, this is device code. So we were pulling in temperature humidity sensor driver, LED driver, accelerometer driver.
Got it. So you don't need that many of these outside libraries, right? You already have most of what you need. You keep the code on device super simple.
Yeah.
And you really maintain a limited number of line of codes down there that does the work of interacting with the hardware, basically, right?
Yeah.
Yeah. Exactly.
And so it's nice. The nice thing is that if it crashes, if I want to deploy new code, I can actually I'll put a hello world at the end of this. Hang on. It's live coding here.
Let's do that.
Oh, hello, Channel 9.
So how many companies do you guys know where the CEO is actually coding live during a recording? Not too many, right?
Startups, quite a few. So I've done deploy, it's been saved, built and deployed, and it's deployed OTA, downloading new code, and device starting. Hello, Channel 9.
Nice.
So that was me deploying. If I'd had a runtime error, it wouldn't have crashed. I don't need physical access.
That's running on this one, right?
That's running on that one. So that was sent. That was sent over a TLS channel. The VM was torn down. New code was put into Flash. But it'll run even if there's no network connection.
So you associated that device with your account, right? So basically, you provision a device to be connected to your account securely. And I guess you have methods to do that at scale, right? We're talking in one device, and you can actually address like tens of thousands.
For one device, use an app. For manufacturing, we have these things we call purple boxes. Essentially, it does optical provisioning. Via flashing LED, but these ones they're secure boxes as well, so I can deploy these boxes and I can deploy entire manufacturing setups to China. The factory has no access to my IP. I can see every device they've made in real time. I can change the software that's loaded on a device up till the second it's powered off. So it's essentially a curated manufacturing flow, secure the whole way through. I can build trusted products in an untrusted factory. So one of the things at Apple, when I was there, under my watch, it was kind of about 100 million phones that were made. Nothing, I'd probably do that in a couple of weeks now. But it seemed a lot at the time. But Apple had a connected manufacturing flow. It was the first thing they'd done on the first iPhone, the first time a fully connected flow. It's really powerful. You can actually collect stats from production and look at like tolerances, voltages, stuff like that. Actually, real time, keep that in the database, data mine that stuff. It's really useful. So you've got these things, you deploy it like this. It's the same code we run on any Imp. So you could have run the same code on the Imp we did 5 years ago, 6 years ago. It's all compatible. Nice. And you can hear this logging coming out, some telemetry being sent. But this is all sending to Azure IoT Hub. So if I flick window, and here we have an IoT Hub thing. So this
that's
one,
IoT Central. There's an application there. Which is actually powered by IoT Hub under the hoods. But so IoT Central there. So basically, if you want to connect directly into that SaaS offering of ours, we have plenty of videos for that, guys. So you have real-time data coming in. You can implement analytics. You can localize the device. What GPS we're saying is not working right now.
GPS is not working. So we've got that's somewhere near us. There's a lake there. If I wave this around, you'll see some stuff. Actually, I was carrying some in my backpack, and one of the developers in Germany was just like, "You had a lot of coffee this morning. You're moving around a lot." But you can see the max acceleration, all this stuff.
There you go. And we have like time series insights for that. So there's that like 30 seconds delay for data to show up, and then you have like the properties and settings that are showing up down there.
And we've got other bits here, and we can actually also, we can show like device twin stuff. So it's like we're flashing yellow right now. If I change this to red and do update, then it'll push
that
it.
Thing is now red.
So that was actually updating the device twin. The device twin is being sent to the thing in real time, and it's actually all. Some people actually say, "Oh, well, you're sending it through another VM. Doesn't this make it slower?" It's actually not. I mean, we have customers. We've done tests, gone entire loops, and we're like actually can be 100 microseconds more than the ping time. Which is pretty good. It's actually very, one of the things you think about actually, the harder crypto you do on the small embedded device, the slower it's going to be. So obviously this is AES and stuff.
And if you want to optimize, you were saying that you have your multi-tenant version of Electric Imp Cloud, right? But then you were saying that customers can actually get their own one. So they can actually decide to host it in the same data center as their instance, or IoT Central, or IoT Hub, same regions for us.
Or even multiple regions. We have customers who they have data protection requirements that in Europe they have to have the data stay within Europe. So they have a region in Europe, data stays there, US, but they can still deploy code to every device from one place. So we have that was me shaking it.
Awesome. Well, nice. And so that you were saying that integration actually is seamless. The code is on GitHub. People can use it and leverage that. The shape that it takes in the code is actually. Can you show us real quick, like the calls to like sending a message to the backend?
I can now. I didn't write this code, so I'm just gonna.
We're gonna find it once again. We're just improvising here.
This is we'll find this stuff. Let's see. On twin updates, future twin properties. It's the reading as fast as I can. On method,
on connect. So actually, you can see here Azure IoT Hub. You have a library that basically does direct method response. That's for the direct message. That actually certainly have been changing the color of the LED through that direct method.
So when a connection is established, enable incoming messages, enable the twin, enable direct methods. And this is all event driven. The nice thing about being event driven, Obviously, on the device side, it helps a lot with power.
Yep.
Because our OS will deal with clock management, CPU state management, everything automatically.
Yep, yep.
So whatever peripherals you use, our OS works out the best clocking strategy and so on, and it's just done.
Okay.
So instead of going through a 2,000-page data sheet, you can just write your code and go, oh, great, I'm idling at 30 microamps. Good.
Awesome. So basically, you have like the device side figured out. We have the cloud side figured out.
Yep. And
it works together.
You guys have the data stuff figured out as well, yeah. So it's essentially, I mean, we have had comments that like, oh, this is hard to demo because it's too easy. And it's like, well, IoT, that's one of the things here is that it's always very easy to show a simple demo. Mm-hmm. But what really makes or breaks, and we've seen IoT deployments, is how you deal with the corner cases. Mm-hmm. Corner cases, I mean, IoT is essentially a big bag of corner cases. Yep. What happens when it's offline? What happens when it goes out of coverage? What happens when da-da-da-da-da? And really, the programmability here, there's really no substitute for code, unfortunately. Code has to be written at some point.
Which is good for us.
but the point is that in the cloud you can generally rely on resources being available, servers being up, there's fault tolerance and all this type of stuff. When you're dealing with communications links, there's often one communications link. There are problems here and there. There are hackers trying to attack the stuff. There's power constraints. And really being able to program the stuff means that those corner cases that would hold you up in some of the more drag and drop methods, they don't hold you up. You can ship. And this has really proven itself on millions of devices now in the field on this stuff. Yeah,
and everything super securely.
Yes.
So actually is one of the things we're talking from the get-go. Security is key and actually is handled. So I always hear people saying like, yeah, for security you have to implement complex things. No, it doesn't have to be complex, right? You can actually have a simple way of implementing security all the way from down there, the hardware, up to the cloud.
There's a lot of complexity involved, but we're, you have to start from the beginning with really good tenets of what you're going to do, and it's like this is secure against hardware probing, physical access, not a problem. There's no JTAG and stuff exposed. It's not everything's on die. But security is, it's a way of life. One of the things we actually did is we did the UL 2900-2-2 Cybersecurity for Industrial Control Systems certification. It's actually not on the cellular module because they don't have a test for cellular right now. But on our Wi-Fi Ethernet modules, those have been certified, which actually means they've done static analysis and fuzzing and adversarial testing against it, and they do it every year to recertify. Okay. And part of it is, my hope personally, the reason we did UL and jumped on this standard early on, is that security is one of these things where people go, oh, our thing's secure. And security right now is mostly someone's word against someone else. It's like, oh, but these pen testers checked it, and it's like, are these guys any good? Is that a good firm, or are they monkeys? I don't know. So it's like having a recognized name say this is it's an arbitrary standard, sure, but it is security arbitrary standard, and we test it independently. Is a good thing, and I'm hoping that what happens, especially industrial, where you have a big footprint anyway, is that buyers start going like, this must have UL 2900. That's what's going to actually start driving security, is that if it becomes a checklist for a buyer, it's going to filter the whole way down through, and developers are going to do secure things. Totally
aligned with you on that. Totally aligned.
Cool.
Awesome. Thanks, Hugo. That was an awesome demo. We're going to add some links on the post here for people to follow up. Where can they find the board, and how they can get started, and how they can start sending it up to IoT Central and controlling the device from there.
That's great.
Thank you guys for watching the IoT Show. Don't forget to subscribe.